Moving into the next section, which is exploring angle pairs. Before we can look at the first problem, we've got to take a look at the different types of angles. The first set of angles that you need to know are adjacent angles. These are two coplanar angles that share a ray and do not overlap. Basically what this means is that they're next to each other. Then we have vertical angles. Vertical angles are two angles whose sides are opposite rays. And vertical angles are always congruent. You can see that in the illustration that two lines make up the vertical angles and that the vertical angles are always opposite each other. They're never going to be adjacent. Then we have complementary angles. Complementary angles are two angles whose measures add to 90 degrees. To be complementary, they do not have to be adjacent. So we could have one way over there and one way over there. As long as they add to 90, they are complementary. The final angle pairing is supplementary. Two angles whose measures add to 180. And just as you had with complementary angles, supplementary angles do not have to be adjacent. Looking at problem number 1A, we have identifying angle pairs. We're going to use the diagram to determine if each statement is true, and then we're going to explain why it's either true or false. So the first statement is angle BFD and angle CFD are adjacent angles. So you want to find out where is angle BFD, and you can see that angle BFD has now been highlighted in orange. In order to be adjacent to BFD, the next angle cannot overlap it, and it either has to share ray FB or ray FD. So we're going to look at where is ray or angle CFD. And you can see that when it highlights it in green, it overlaps angle BFD. Therefore, the two angles are not adjacent because they overlap. Looking at statement number 2, angle AFB and angle EFD are vertical angles. So again, we're going to identify angle AFB with the orange highlight. In order to be vertical, it has to be directly across from it, and it has to be the same angle measure. You can see that in this case, ray FA is an opposite ray to ray FD, but ray FB and ray FE are not opposite rays. Therefore, the two angles cannot be vertical. There is another way you could prove this. If you look at angle EFC is a straight angle. Angle EFA plus angle AFB plus angle BFC is going to be equal to 180. When we substitute the values that we know into that equation, we get 62 plus angle AFB plus 28 is equal to 180. That means angle AFB plus 90 is equal to 180, and angle AFB is then equal to 90. Angle EFD is 118. Since angle AFB and angle EFD are not equal to each other, then they're also not congruent to each other, so they are not vertical angles. In the final statement, we are given that angle AFE and angle BFC are complementary angles. So this means that angle EFA plus angle BFC must equal 90. When we plug in the given measurements, we get 62 plus 28 equals 90. Because the sum of angle EFA and angle BFC is equal to 90 degrees, the angles are complementary. For problem number 2, we're asked, what can we conclude from the information in the diagram? The very first thing we're going to look at is the markings that are given on the diagram. And that tells us that angle 1 and angle 2 are congruent by congruency markings. We also know that angle 1 and angle 2 combined are vertical to angle 4 because we do have two straight lines there that form vertical angles. This also means that angle 3 is vertical to angle 5. Then we know that angle 1, angle 2, and angle 3 are supplementary because the line that they all have in common, or the line that the vertex that they all come to, is a straight line, which means it's 180 degrees. This means that the measures of angle 1, angle 2, and angle 3 are equal to 180. We can also tell that angle 3 and angle 4 are supplementary, which means that their measures are also equal to 180. 4 and 5 are supplementary, which means their measures are equal to 180 as well. Finally, angles 1, 2, and 5 are supplementary, so angles 1, 2, and 5 added together all equal 180. Then we're going to look at which angles are adjacent. Angle 1 is adjacent to angle 2. Angle 2 is adjacent to angle 3. Angle 3 is adjacent to angle 4. Angle 4 is adjacent to angle 5. And angle 5 is adjacent to angle 1. We're now at the linear pair postulate. The linear pair postulate is very similar to supplementary angles, and they can actually be fairly confusing because of their similarity. Remember that with supplementary angles, they don't have to be adjacent. So one can be over there and one can be over there. But with the linear pair postulate, they have to be adjacent angles. So if two angles form a linear pair, they are supplementary. That's rule number 1. And again, the difference between the supplementary angles and a linear pair is that supplementary angles do not have to be adjacent. A linear pair must be adjacent and equal to 180 degrees. That takes us to problem number 3, finding missing angle measures. This problem reads, angle KPL and angle JPL are a linear pair. The measure of angle KPL is equal to 2x plus 24, and the measure of KPL is equal to 4x plus 36. What are the measures of angle KPL and angle JPL? So what we know is that angle KPL and angle JPL are a linear pair, which means that they're supplementary, so we can add them together and they equal 180. We can then substitute the measure of angle KPL as 2x plus 24 and the measure of angle JPL as 4x plus 36. Substitute these in to the angle addition postulate, and we have 2x plus 24 plus 4x plus 36 equals 180. Combine like terms to get 6x plus 60 equals 180. Subtract 60, so 6x equals 120. Divide out the 6, and x equals 20. Now, to get the measures of KPL and JPL, substitute x back into the quantities. So the measure of angle KPL is equal to 2 times 20 plus 24, which gives us 40 plus 24, which gives us a measure of 64. Now, what we should get with angle JPL is 180 minus 64, which would give us 116. So if we don't get 116, we did something wrong. So we're going to substitute that in. 4 times 20 plus 36 gives us 80 plus 36, which is 116, which is exactly what we expected. The next piece of information you need moving forward is that of angle bisectors. Any segment, ray, or line that splits an angle into two congruent angles is considered an angle bisector. We're going to use angle bisectors in the next problem. So we're going to use the angle bisector to find angle measures. In this problem, we're given that ray AC bisects angle DAB. If the measure of angle DAC equals 58, what is the measure of angle DAB? So measure DAC is half of the angle. Measure DAB is the full angle that we're looking for. So our given piece of information is that ray AC bisects angle DAB. So we know that angle DAC is also congruent to 58. We also know that angle DAC is congruent to angle CAB, so we know that that angle's measure is also 58 degrees. If we add the measure of angle DAC and the measure of angle CAB, we're going to get the measure of angle DAB. So we're going to substitute in 58 and 58, and that gives us 116 equals the measure of angle DAB.